Hey guys, Wild Ox Studios here, and I'm gonna try to talk through um, subject matter that a Patreon member has brought up um, on the Ready Player Me tool pertaining to mesh persistence through multiple level loads, and this can be handled numerous ways. And I thought it would be a good idea to bring up the Cedric's network uh, compendium just to kind of go over what is available in multiplayer, because this would be handled differently if you're expected to have multiplayer replication behavior for this type of thing. First and foremost, on this diagram you won't see a game instance, and but if you look up what the game instance is and how it's handled, the game instance is the client's instance manager to say, hey, I've started the application and I'm persistent throughout the entire application. This makes this a really good place to store persistent information between level loads and just things that are going to get destroyed and recreated. It's a good place to go fetch that information for a single client. But if you need to replicate those values, as you can see, on this graph here, the game instance isn't shown, and that's because the game instance is unique to each application. So the server would have a copy of its game instance, and if you set this up properly, all of the clients would have that same copy. You would need to replicate an integer value from either the game mode, or the game state, either one, because all of the clients would then be aware of that replicated value. So what that means is you could store the mesh in the instance, but you would have to RPC out to the client for the client to grab that mesh information. And because the server has a copy of that same struct or that same value on its side, you could then replicate that from the game mode, from the game instance, out to the rest of the clients, and it would persist. But the server cannot directly fetch from a client's game instance, and the client can't communicate changes from that game instance back out to the server. You would have to fetch it from its local game instance, and then you would have to RPC it into something like the game state, or RPC it into another value, so that it could replicate out to all the other clients. So in a multiplayer environment, you would have to do this a little bit differently. And I just wanted to touch on that a little bit. It's still possible, usually because the game instance will be persistent across all clients, so the server knows about itself, and then you could replicate an integer value out to say, hey, make all these things line up across all of my applications. So it's a little hairier there, but I just wanted to go over it briefly. So we'll jump into the Ready Player Me tool, and this is just kind of the version 2 tooling. We have a HUD that calls forth the Ready Player Me avatar system. You can pick a mesh, hit next, and then it's going to run this whole HUD logic and then spawn you in with the character that you selected. First run usually takes a little bit for it to refresh, for the API callback to happen, but shaders need to process, etc. But we should be good to go at this point. If I hit play again, everything should be good. And again, I'm on my lunch break, so if I'm going a little quickly, hopefully you guys can rewind the video and rewatch whatever you need to. So first things first, I'm gonna set up a couple of maps to, and I'm just gonna duplicate this map and name it level 1. And then I'm gonna duplicate this map and name it level 2. And we'll load into this. We can just save everything. That's cool. And then to make these levels be able to be differentiated from each other, I'm gonna make some, I don't want to delete that, material changes, just so we could tell the levels apart. Let me save this. I probably should have just not did this just yet. I think underneath demos, under meshes, we'll have a cube material. I'm gonna duplicate this and name it like blue, and then I'm gonna duplicate this and name it green, and we'll go update these colors. I want a lighter value. Cool. And we'll drag this in here, and then we'll duplicate this map now to be level 2. That's cool. We can save it, and then we'll update the blue mesh for that level. And drag this on here. And we should be good to go as far as levels go. I'm gonna save this. And then, yeah, we are likely going to need to create that game instance that is going to persist, that's going to allow for persistent data. The controller gets destroyed between map loads, so you can't really store it there. Player state, also the same thing. We could create like a save data object and store it, but that's really for like if the application was to close down and load back up and you wanted to load those saves from disk. Just the application loading up, storing the data locally in the application and persisting that throughout level loads is a little bit different. And the game instance is a really good class to do something like that with. Then your save system could load the game instance, right? So you could call upon the save system, push it into the game instance, and write logic around that. So I'm just gonna go over getting data into the app and keeping it persistent throughout level loads. I didn't want to make a base actor. That's not what we wanted to do. So if you come down here and you type in game instance, base is fine. And then underneath your project settings, you'll want to go apply this under maps and modes right here. And we're done with that. Since it inherits from the base game instance class, nothing's really changed in it. That's fine. We're gonna need 2 variables. We're gonna want this to be called first load or something like that. And then we're gonna want this to be storing the mesh object. And we'll look for a skeletal mesh object reference. And I think we should be good here. I'm gonna expose this first. Actually, I don't think we need to. We're calling it directly from the blueprint. We're not gonna have it on anything outside in a level, so yeah, that should be good. I'm gonna go back to the example map, and from here, in the world settings, right here, the HUD class is what gets called on begin play, and then that HUD class is what's setting the avatar up, and then it reaches out to game mode and says load the avatar, right? So if you were wanting to keep like server controlled spawning, etc., you want your game mode to be that source of truth for everything. So that's the reason why this order of operations is set up. This interface just calls the controller and says, hey, controller, spawn a character at a player start, and push the, load avatar call to that pawn. What we're going to do here is we're gonna get the game instance. We're gonna need to cast it. And then just in case we ever want to use it in here again, I'm gonna promote this to a variable. And then I'm gonna go ahead and scoot this over, and by default, first load needs to be set to true. It's always gonna be, yes, this is my first load. In the HUD, we're gonna get that first load, and we're gonna say, hey, if this is the first time through, we do want to set up the avatar for the HUD. And then it's going to go through this, it's going to bind on the event, and then it's going to get here, and then this is where this thing comes in handy. We're going to set first load to false. If you've already been through these motions, and at this point all of the logic should still function the same. And if I hit escape and I hit play again, because the game instance spins up fresh, it's destroyed and respun up fresh with every instance that you play in instance, for example, it's gonna always be true that first time through. Next thing we want to do is create a blueprint that is going to handle map loading, and this can be a base actor blueprint, it's fine. And I'm just going to call it like load level, and we should have a default scene room, which is great. I'm going to add a couple of things. I want a billboard, and this is just a really cheap way for me to understand where it is, and I'm going to set this to like a level instance type of thing and make it stream desired. That's fine. And then I'm going to add a box collision, and because I want this thing to be really cheap, I'm going to modify the collision channels, and I'm going to say, I mean, you can do overlap only pawn, but I want it to be even cheaper than that. I only want it to overlap the pawn and ignore everything else. So we have this saved. Now you can drag directly off the box on component hit or begin overlap. You also have this on actor, which is basically any component within the actor that overlaps, it'll fire event for. So this is fine right here. And then you have this open level by name. So we'll set that up, and then I want to promote this to a variable because I want this to be instance editable. Based on the map I put it in, I want to update this level name. So we'll drag this out into the world. Put it over here somewhere, that's fine. And as you can see, because we have that variable, you know, exposed, this can be level 1. And then we'll go into level 1, that's fine, we save all this. Same thing, we want to drag this blueprint out. And this can be level 2, and then we'll go to level 2 and we'll make level 2 point back to the example map. And I'm pretty sure I just called it example map. Yeah. So we'll go back here and we'll say that. Let's go edit this guy again because I want to make sure that the billboard is visible in game. I don't want it to be hidden because that's the way I'm going to be able to see if it's there. So all of that should be set up. And at this point, if we hit play and we go through the motions, the branch is going to work. it's going to load your avatar, and then you're going to go to the load level call, and then you're going to be stuck in space. Nothing's happening. And this is expected because right now we don't have a default pawn set up. We're handling that manually through our calls. So now if we go over here, we'll see like this logic's working. On the first run, we did this. On the second run, we've done nothing. So that's the reason why we're not spawning anything, because the game mode load avatar calls out to the controller, and then the controller is actually what's handling the spawning. So if we go to the controller, you'll see the build avatar gets all the player starts, spawns, and then possesses. So you can make this into a function and clean this up later, but really we just need this logic, and then we need possess, and we're not loading the ready player me anymore. That's not what we're gonna do. We're gonna say we want to set a mesh that we have saved away, right? So I'm gonna add a custom event. This is gonna be like load character mesh. Actually, this is just probably spawn load character, because we're building the avatar here, and this is just loading the character. So that, I mean, that's probably a really good name for this. Yeah. So again, we can pass this back through the game mode, but for the sake of time and for the sake of video, what I would need to do is create another. It's fine. You know what? Let's just do that the right way. I don't want to cause any confusion. So let me go get the game mode real quick. So we have this interface here that's building the avatar. There's multiple ways to get to this. If I double click this, we can add a new function. Yeah, load character should be fine. So logic is going to be essentially the same. Casting to the controller, and then here, if we double click this, you'll see we're building the avatar based on this logic, right? Here we're gonna do something a little differently. So we want to call right. We want to call the load character instead of build avatar. And then in the HUD, under false, where this get game mode interface call is called, we're going to do the same thing for false, but it's not going to be load avatar, it's going to be load character from the game mode. Right? Which is here, calls the controller at this point, and then spawns and possesses. So if we test this out, everything should work minus the saving of the mesh. So we're not going to be on first run anymore. We're not going to call anything about loading an avatar mesh. We're just basically spawning the character. So, which works. We're able to transition between levels, right? So now we need to save the mesh. I'm gonna do a save all real quick just in case we crash. Don't need the interface open anymore. Don't need this anymore. Don't need a game mode anymore. Low level BP is fine. All right. So the only thing we have open, we have the game instance open, which we don't need anymore. Actually, I'm going to back out of here and make sure this is all fresh. All right. So on the load RPM event, where the Ready Player Me actor is loading the new avatar, and it's setting the mesh on the callback, and then it says, hey, get rid of the mouse cursor. I've done everything, remove all the widgets, etc. What we're going to need to do is save this mesh off to the game instance. Let's see if we have any references to the game instance in here. I don't think we do. So I'm going to actually add an event begin play. Going to get the game instance. Going to cast this. Promote it to a variable so we have it saved. Means this information can be used anywhere. Over here I'm going to get it, and I'm going to say, hey, let's set the character mesh. And hopefully that doesn't yell at me. Alright, so we're just saving this mesh after we've ran through the setup for the load Ready Player Me, right? Now, because we're going to take a different code path, we're gonna want to be able to load whatever that set value is. So I'm going to actually comment this: save mesh to game instance for later. I'm gonna add a new event. And I'm going to be load mesh from I'm just going to call this load saved mesh. And I'm going to get the game instance reference. I'm going to get the mesh asset. Actually, it's saved as a mesh asset, so I'm just going to get this, and I'm going to say set skinned asset. Pretty sure that's what we have to do. Set set skinned asset and update, and then we'll get the character mesh from here. It's basically doing what we did below, but in reverse. And then I'm gonna say loads mesh from game instance. All right. So the pawn actually controls that behavior, which is cool. Pawn will be loaded. It'll be possessed or whatever. And the only other thing we have to do now that we have that logic on the pawn is in the controller where we're spawning it, load character. Instead of just spawning and possessing, we're going to actually load the mesh underneath that false condition from the HUD. So you'll just pull out here and you'll say load character. Nope, that is the wrong thing. We'll do load saved mesh. That is the right thing. So you're loading the saved mesh from the game instance, and then you're possessing now. So if we test, we hit next. Mesh is set, saved in the game instance. We load into the next level. Still the same character. Doesn't present you with the load HUD anymore. Load the next level. Same thing. So hopefully that kind of goes over, pulling data from an external source, storing it within the application. As long as the application is running, the variable is saved. It's available to be pulled between level instances. Even though the pawn is destroyed, the controller instance could be destroyed. You still have a persistent place to store this information. Now, if the application was to stop and start again, this is gone. It only exists in memory in that instance. So in that case, yes, you would need to create a save game object and stash it, and then load from it into your instance, and then populate the character based on if the save game object exists or not, or if you want them to be able to override it. But anyway, huge shout out to all the Patreons, and also the marketplace asset purchasers, etc. Everyone following Wild Ox Studios, I really appreciate it. And you guys have a nice evening. And it's only 30 minutes in, so I was able to get this done during the lunch break. Woohoo. Y'all have a good week, guys.